Today, in our continuing series of videos on benzene and aromaticity, we will in this last video see the structure and uses of some selected benzene derivatives, namely DDT, Saccharine, BHC and Chloramine. This is as per the PCI syllabus for SYB Farm semester 2. The first derivative you will see is DDT. This is the chemical structure and it is basically an ethane derivative. At the one position there are 3 chlorine atoms, at the 2 position there are 2 para-chlorophenyl moieties. So the IUPAC name is 11-222 trichloroethane and 11-diol bis 4-chlorobenzene. The CAS number is 50-293. This is a unique chemical abstract registry number. Each compound gets a unique number which is not identical with any other compound. Its molecular formula is C14H9Cl5. The molecular weight is 354.48. It's a colorless, tasteless and almost odorless crystalline chemical compound. It was first synthesized in 1874, but a German chemist called Müller in 1939 found out that it had substantial insecticidal action, particularly on the mosquitoes, and which were spreading the diseases like malaria and typhoid worldwide on an epidemic proportion. And for this work of his, he got the Nobel Prize of Physiology and Medicine in 1948. And during World War II, it was widely developed as an insecticide to save the civilians and troops from the casualties. However, due to its carcinogenic potential and its very adverse effect on the nature, particularly on the wildlife and environment, it has been banned. Nowadays, we don't use it. The second derivative is saccharine, which is chemically a sulfimide. It is called as benzoic sulfimide, and this is a sulfimide moiety. This is somewhat similar to phthalimide, where you have got a cyclic amide with 2 carbonyl groups. So this is of course having sulfur instead of carbon, so called as sulfimide, and nitrogen is common. Sodium salt of saccharine is highly water soluble and highly sweet, 300 to 400 times soluble than sweeter than the common sugar or sucrose we use, and it has got 0 calories. So therefore it is very much useful for patients suffering from diabetes. And so in their tea, coffee, beverages, drinks, cool drinks, they take saccharine, and even in the sweet shop, many of the sweets, particularly for diabetic patients, are prepared by using saccharine. However, it has after effect of bitter metallic taste. So, therefore, it has been replaced with other artificial sweeteners like your aspartame and some natural sweeteners, and which are available now in the market as sugar-free gold and sugar-free natura. Preparation, it is synthesized from toluene by action of chlorosulfonic acid. So it is a simple chlorosulfonation reaction which results into 2 isomers, ortho and para. Para is not used here. It is useful for some other purpose, but the ortho isomer is then subjected to or dumped in ammonia, subjected to reaction with ammonia. So this chlorine is replaced and an amide is obtained, and then this is oxidized to cyclization to the target compound. Next is benzene hexachloride, which is the abbreviation is BHC, or also commonly known as lindane or gamaxine. It is actually also known as gamma hexachloride cyclohexane, gamma hexachloride cyclohexane, or gamalene. And the IUPAC name is 1R, 2R, 3S, 4R, 5R, 6S, 1, 2, 3, 4, 5, 6 hexachlorocyclohexane. So it is This is a stereoisomer which is active. It has got a Cas number of 58-89 and a molecular formula C6H6Cl6. The molecular weight is 290.83. It's an organochlorine chemical variant of hexachlorocyclohexane that has been used in agricultural and pharmaceutical industry. For agricultural industry used as an insecticide, while in pharmaceutical industry or medicine it is used to treat lice and scabies, and it is still used particularly for scabies in the form of lotion. Linden is a neurotoxin that interferes with the GABA neurotransmitter function of these microorganisms by interacting with their GABA receptor chloride channel complex at the pectotoxin binding sites. It does have effects on the humans, on the nervous system, liver and kidneys, and is supposed to be a potential carcinogen, and therefore it is only used for external use and very carefully. It is also whether it is an endocrine disruptor is not clear. The WHO classifies linden as a moderately hazardous substance, and its trade is restricted and regulated under the Rotterdam Convention on prior informed consent. In 2009, the production and agricultural use of linden was banned under the Stockholm Convention on persistent organic pollutants. A specific exemption to this ban allows it to continue to be used as a second-line pharmaceutical treatment for lice and scabies, where it is only used for topical or external use. Next one is Chloramine D, which is tosyl chloride, a common name, or N-chlorotosilamide, or chloraseptine, chlorazole, chlorina, disulfin, halamide, hydrochlorazone, trichloro, and minochlor in various countries. So this is paratoluene, you can say sulfonamide, chloride derivative, and it is generally used as a sodium salt, therefore it is mid-soluble. So it is chlorinated and N-deprotonated sulfonamide used as a biocide to kill the microorganisms or insects, and is a mild disinfectant. It is a white powder and gives unstable solutions with water. It is highly reactive and it decomposes with water. It is an algicide, bactericide, virucide, fungicide and germicide. It is also effective against mycobacteria such as tuberculosis, as well as foot and mouth diseases and avian, that is bird influenza. Chloramine is prepared by the reaction of paratoluene sulfonamide with NaOCl, that is sodium hypochlorite, which is nowadays also used for sanitization to protect as a preventive measure for to stop this spread of coronavirus. Sodium hypochlorite is nothing but passing chlorine gas in NaOH, and some 5 to 10% solutions are used. So in situ sodium hydroxide and chlorine gas, that solution is sodium hypochlorite. So that ends our chapter on the benzene derivatives. 4 are there under the syllabus and we have seen them in brief. I am now going to solve some MCQs which will be very, very useful to the students. Let us start with the first MCQ. Choose correct alternatives. Benzene reacts with concentrated HNO3 in presence of concentrated H2SO4 to give nitrobenzene. This is an example of electrophilic aromatic substitution, electrophilic addition, nucleophilic aromatic substitution, nucleophilic addition. What is the correct answer? The correct answer is first, it is electrophilic aromatic substitution. Benzene undergoes substitution reaction more easily than addition reactions because it has a cyclic structure, it has double bonds, it has 6 hydrogen atoms, there is delocalization of electrons. So what is the correct answer? there is delocalization of electrons. Pi electrons are nicely and uniformly spread above and below the flat benzene ring. That is very much essential for benzene to undergo very facile electrophilic aromatic substitution. Toluene on nitration will not give which of the following derivatives: orthonitrotoluene, metanitrotoluene, paranitrotoluene, orthoparadinitrotoluene. What it will not give? Let us see the answer. It will not give metanitrotoluene because the methyl group on the toluene is orthopara director, so you will never get a meta substitution. The CC bond length of benzene is greater than CC bond length of ethane, CC bond length of ethylene, same as CC bond length in ethylene, intermediate between CC bond length of ethane and CC bond length in ethylene. What is the correct answer? Yes, it is 4. It is intermediate between CC bond length in ethane and CC bond length in ethylene. Next MCQ. Choose correct alternatives. The carbon atoms in benzene rings are sp3 hybridized, sp hybridized, sp2 hybridized, none of these. Which is the correct answer? Yes, 3. All carbons are identical and they are all sp2 hybridized. The underlying fact for the statement: what is the difference between 1-chlorobenzene and 2-chlorobenzene? One is orthoisomer, other is metaisomer. One is liquid, other is solid. One has chlorine at 1 position while other has at 2 position. 4. There is no difference, they are one and same. What is the correct answer? Yes, same. Because monosubstituted benzenes, all carbons are same. So there you cannot call it as 1-chloro, 2-chloro, 3-chloro, 4-chloro, 5-chloro, 6-chloro, etc. Friedel-Crafts alkylation and acylation require AlCl3 to first abstract chloro to form AlCl4 and then abstract the proton to create acidic medium to dissolve the reactants. None of the above. Let us see the answer. It is first. Yes, AlCl3 will first abstract the chlorine of the chlorine or halide or whatever it is. Depending, then if it is bromine, then you will have to use AlBr3. It will abstract the chlorine of the alkyl chloride, form AlCl4, and therefore the alkyl group will go as an electrophile, get attached to form the benzonium complex, and the extra hydrogen of that benzene where it has got attached will be then abstracted by AlCl4. Halogens are mild deactivators but still orthoparadirectors. True, false, none of these. They are metadirectors. What is the correct answer? Correct answer is true. Though halogens are electron withdrawing mildly, they are still orthoparadirectors. Next is 4-nitrobenzophenone can be made by nitration of benzophenone by Friedel-Crafts alkylation of benzophenone with appropriate halide, by SC alkylation of benzene with appropriate acyl halide, and none of the above. Yes, third is the correct answer. You have to do the Friedel-Crafts acylation of benzene with appropriate acyl halide, that is paranitro benzoyl chloride. Instead, if you do the nitration of benzophenone, you will get it at the meta position of one of the rings. Phenol can be made from benzene by hydroxylation of benzene, hydrolysis of benzene, oxidation of benzene, conversion to benzene sulfonic acid salt followed by its hydrolysis. Yes, 4. That is the common procedure. You cannot do hydroxylation of benzene is a very vague answer. Hydrolysis of benzene is very difficult, and oxidation of benzene is also very difficult. It will break the benzene ring, or it will form some other types of compounds. Aniline can be made by reduction of nitrobenzene, amination of benzene, deamination of orthophenylamine, none of the above. What is the practical answer is first, that is reduction of nitrobenzene with iron HCl also will give. Aryl halides are more reactive than alkyl halides. True. False. None of the above. Depends on the nature of the halide. Yes, false. Aryl halides are less reactive than alkyl halides because the benzene ring has a minus I effect. Benzene ring has minus I effect, and also the resonance plus R effect. So it will not undergo the replacement of the halogen that easily unless and until you introduced an electron withdrawing group on the benzene ring. Benzoic acid can be prepared by oxidation of toluene, by oxidation of benzaldehyde, by oxidation of benzyl alcohol. All are true. Answer is all are true. All will lead. Simple KMnO4 oxidation will lead finally to benzoic acid only. DDT is chemically dichloro, diphenyl, trichloroethane. Diphenyl, dimethyl, trichloroethane. Dichloro, dimethyl, trichloroethane. None of the above. Yes, it is dichloro, diphenyl, trichloroethane. We just saw. Saccharine is chemically benzene sulfonamide, benzoic sulfimide, benzosulfonyl chloride, none of the above. It is the second answer that also we saw. It is a cyclic sulfimide, so benzoic sulfimide. And the last MCQ is BHC is chemically benzene hexachloride, gamma hexachlorocyclohexane, linden, all of the above. Yes, very true. All three are the names of BHC. So thank you very much, and I hope these MCQs will be useful to you for your exam, because one type of questions as per the PCI syllabus are MCQs. You get 10 MCQs. So thank you very much and happy learning.